Okay, today we're going to continue on chapter 6 on functions, and this is section 6.2, linear functions. So linear functions, what are we going to do? Well, we're going to treat them in the same manner basically as a linear equation, but here one input gives one output. The function is going to have the form f of x equals mx plus b. So kind of what we were looking at sometimes in the last section. And remember, f of x, that's just equal to y. So if you have to do it, you can always say that's equal to y, but the actual function format is f of x. And then we just have our mx plus b, which is the linear format where you have slope times x plus the intercept, where m and b are basically your coefficients, or slope and y-intercept, like I just said. Now, the slope can be written in function notation in the following manner. So slope usually is the difference in y over the difference in x. Well, what is the y? Well, it's f of x. So what we can do is say f of x2 minus f of x1, which is y2 minus y1 over x2 minus x1. And so our points really are x1 and then f of x1. So basically you have your input. This is your output after you plug in x1. And your input is x2, and then your output is what is f of x2. And so those are your ordered pairs, and that's how you get your slope. And then our point slope formula in function notation is going to be f of x is equal to the m times x minus x1 plus y1. Now, if you remember, it's really y minus y1 equals m times x minus x1. And what we do is we add y1 to both sides. And so we get y is equal to m times x minus x1, and then plus y1. And what is y? Well, that's f of x. And so that's how we get this, which is just m times x minus x1 plus y1. So that's how we get it from our original point formula for the point slope formula that we're used to. So it's still the same thing. We can go back and use this if we need to, but this is another way to look at it. And again, m is just your slope, and then x1, y1 are just points on the line, so any points that you can choose. All right, so here is an example, and it says if f of x is a linear function, and we know that f of 5 is equal to the 8 and f of negative 2 is equal to negative 13, we want to determine the linear function. Well, what do we know? Well, we know our points because we know that 5 is x, and we know y is equal to 8, and so that's actually 1 point. And our other point is going to be a minus 2 is going to be for what we plug into x, and we get out a minus 13. So these are our two actual points. But if we look at it, we can do our slope formula using our functions f and our values of x, or we can use these points here. So basically it's going to be your f of x2. Now, which one you use is x2 and which one you use is x1 is really doesn't matter. Let's say I'm just going to take the first one here. It's 8 minus a minus 13. So your 1 minus the other. Then I do the other. 5 minus 2. And so this is going to be equal to 21 over 7, and we can reduce that to 3. Okay. Now, what we're going to do is we're going to plug it into that formula we had before and determine the linear function. Well, that was going to be f of x equals our m, which is 3, times x minus x1. Well, I'm just going to now pick this one as my x1. So that's going to be a 5. And then what we had was plus y1, which was the 8. And so now we get 3x minus 15 plus 8. And so that's equal to 3x minus 7. And so my linear function is f of x equals 3x minus 7. So again, that's using going back and plugging these in and showing what the two original points were, and then we can use our normal slope formula, and then we can use the function formula for the function for the linear function in the function format, and that's already solved for it, and we get out our linear function. Now, there are applications of this. So the linear modeling, where the slope is defined as the average rate of change and the y-intercept is thought of as the initial, fixed, or startup value. And so that is going to be, the startup cost for a business is, $500 or something. Or the fixed cost every month for this is going to be $7,000 or whatever it is. Your y-intercept is going to be that initial or the fixed or the startup value. And then you're going to have average rate of change, which are going to be basically output units per input units. And so example, miles per hour, where the miles are the output and the hour is the input unit. So we're going to have our slope is change in output over change in input. And we can put those two together, and what we can do is we can actually create a linear function. And so what I'm going to do is I'm going to kind of go backwards. I'm going to start here writing the linear function. And then from there, I'm going to determine the y-intercept. And from there, I'm going to determine the slope. And so it says the cost function, c of x. And so I'll have c of x is equal to, basically, we're going to rent a car for a day is $25 per day plus 65 cents per mile. Okay. Well, 65 cents per mile means we're going to have to take the number here, 65.65, times the number of miles. Well, x is the number of miles. So if we take 0.65 times x, that's going to be our part here that we're going to have. And every day we rent it, it's going to be $25. So plus $25. Okay. And we're just going to rent it for that one day. Now, that is my linear function. The cost of the rental per number of miles is 0.65x plus 25. Now, what is my y-intercept and its units? Well, my y-intercept is 25. So that's 25. And what is its units? The units are dollars, okay, because we know it's $25. Now, what is the slope? Well, the slope is what this is, 0.65. Well, what is its units? So our slope is 0.65, and its units are dollars per mile, because that's what the units here are, dollars per mile. So sometimes writing the function from the words is a lot easier, and then you can go back and say, oh, okay, well, that's my B, this is my M because it's times the X, and then I can do that, and then I can look at my units and say, okay, well, it was $25 per day, and it was 0.65, it was so many dollars per mile, where the X is the number of miles. Okay, and so when you take miles times dollars per mile, you get dollars, so you get dollars plus dollars, and that's going to be your cost. All right, so some examples of converting these like word problem application problems into actual linear functions. So it says the first one, Jeff can walk comfortably at 3 miles per hour. Find a linear function b that represents the total distance Jeff can walk in t hours, assuming he doesn't take any breaks. So this is just a straight linear function. It doesn't have you started off walking so many miles. And so we are b of t is equal to, well, our constant that's change, or the rate is 3 miles per hour. So that's going to be 3. And the number of hours we walk is t. And so that's our slope. That's our, input value. And so depending on how many hours we walk, that's going to tell us how far we walk. And so it's just 3 times t. That's going to be our distance function. Now the next one says a landscaping company charges $45 per cubic yard of mulch plus a delivery charge of $20. Find a linear function which computes the total cost C in dollars to deliver X cubic yards of mulch. All right, well, that's going to be C of X is equal to, well, each cubic yard is going to be $45 per cubic yard. So that's going to be 45 times X, because X is the cubic yards they deliver, and then plus that delivery charge of $20. So that's our delivery charge. That's going to be our intercept. That's the initial or fixed cost. And then that's going to be how much it's charged per unit of whatever we're doing. In this case, it's cubic yards of mulch. So 45 times the number of yards we do, it's going to give us a charge plus the $20, and that gives us the total cost. Now the next one says a salesperson is paid $200 per week plus a 5% commission on her weekly sales of X dollars. Find a linear function that represents her total weekly pay W in dollars in terms of X. All right, so we know it's going to be W of X. Okay, that's how they want it written. And so what are they going to get? Well, they're going to get 5% of the weekly sales And so X is the number of dollars a weekly sales. So whenever we put things from a percent, we always have to convert that to a decimal. That's going to be 0.05. That's going to be the percent times how much she makes, X dollars, and then plus a standard rate of $200 per week, no matter what. So if she sells nothing, she's going to make $200. But if she sells, 50,000, it's going to be 50,000 times 0.05 plus $200. And so that's going to be our function that represents her total weekly pay. So, our basically our base pay plus the commission part of it. All right, we can graph linear functions in two ways. Basically, it's going to be the same thing as if you were plotting a linear function y equals mx plus b, but now a linear function is going to be the f of x equals mx plus b. So it's going to be the same format because f of x, remember, is just y. Just getting our heads wrapped around what does f of x versus the y look like. Okay. So we can do it one way is plotting points and then drawing a line through them, and we get our line. Or we can plot the y-intercept, whatever our b is, and then use the slope, our m, to find additional points before drawing a line through those points. So both ways work, and it kind of depends on how the problem is set up. Okay? Or what they ask for, really, because they're going to usually be set up the same way. So here it wants us to plot points to graph the given linear function. So to plot points means we're going to have some x, and then we're going to have some f of x. And again, it's not y now, it's called f of x. And so those are going to be what we're looking at. So we can plot in, different values here. It doesn't matter what we use. I don't know. Let's use 0, 2, and 4. Okay. So if we plug in 0, so f of 0, what is that? Well, 0 for x, it gives us an output of 3. If we plug in 2 for our input, 3 minus 2 is 1, so our output is 1. Now if we plug in 4 for x, 3 minus 4 is a negative 1 for our output. So now what we can do, if we can get this drawn here, all right, so 0, 3. So that's going to give us a point right there. Then 2, 1. That's going to give us a point here. And then we'll have 4, and then negative 1. And now trying to draw this is going to be the fun part. And so we'll look something like that for our graph of that function. All right, so what do we do next? This one, if we plot points again, what do we have? Well, we're going to have t and f of t, okay? And I'm going to redraw that because that's kind of crooked, so hopefully we can draw it a little bit straighter this time. So we'll have t and f of t. All right, so let's plug in points. And I'm thinking here, I have to multiply by 4. So let's take a 0, maybe a 4, and an 8, okay? So kind of doubling what we did here. So if I plug in 0 for t, that goes to 0, and then I just have 1 for my output. Now if I have 4 for t, 4 times 1/4 is 1, plus 1 is 2. Now if I have 8 for t, 8 divided by 4 is 2, plus 1 is 3. So now I can do this graph, hopefully. So we have 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So 0, 1, that's going to be our first point. 4, 2, 1, 2, 3, 4, 1, 2. And then 8, so that's 4, 5, 6, 7, 8. And that goes up to 3. And so, if it'll stay there. And so now trying to draw that line, we get something like that. Okay, Key thing is we found those 3 points and that gave us the line. And I do 3 for a minimum just because that way if I get 3 points in a line, it's good. 2 points always will make the line, but you could have one of the points wrong. And so I always try to do 3 to make sure they're in line with each other. Same with that first one there. All right, so this one we're supposed to use the slope and intercept to graph the functions. So let's go ahead and just write this here. 1, 2, 3, 4, 5, 2, 3, 4, 5. All right, so what do we have? Well, 0, -5 is going to be our intercept. So 1, 2, 3, 4, 5. So that's going to be our first point. Then our slope is 1, 2. So we're going to go up 1 over 2. Then we'll go up 1 over 2. And then we can go up 1 more. Where are we at? So we're at 1, 2. So we're right here. Okay. And my middle one disappeared now. And now my end one disappeared. All right, so now they're all staying. And so then that would be what my line looks like. Again, started with our intercept 0, -5. Then I moved up 1 over 2, up 1 over 2. And that's going to be how you do it. So that's your change in y, that's your change in x. And so that's how we get to it. Now this one's a little more unique. And so what does this one say if we think about it? So what this is, remember, r of t, that's your function, that's equal to y. And so really this just says y is equal to 4. So we just have the intercept 0, 4. But then no matter what other value we have, always is going to be 4. And so we're just going to have this horizontal line across here that looks like that, because really this is the same thing as 0x and then plus 4. Your slope is 0, which is horizontal. Basically, you're not going to go up or down. And so it's just the slope is 0. And so no matter what value of x you plug in, you're always going to get y is equal to 4. All right, so that's what I have for our linear function.